位的演讲嘉宾的话是来自于美国的听力损失联盟的 Linda。那么他的一个个人介绍，他是美国无障碍的技术消费者与产业联盟的一个联合负责人，他同时也是高丽的大学的一个资深的研究听力学家。他从事沟通无障碍技术的研究、标准发展和公共政策的工作已经20余年。那么 Linda 还参与了面向美国 FDA 为期3年的一个助听器兼容性的一个建议项目。Linda 的话，在华盛顿大学的路易斯分校完成了她的听力言语康复专业学习，所以 Linda 本身是一个听力学专业出身，但是她其实是更多还是参与到这一些技术标准的公共政策的一些制定。那么随他这次的分享，除了会告诉我们说，在美国关于助听器兼容性相关的一些政策法规、残疾人电信法以及助听器兼容性法它制定的一个起源和历史，也分享了他们 HAC 工作小组以及 hearingtracker.com， 包括美国助听器行业协会他们发布的多项用户调研数据。所以这些数据会让我们了解一下，美国的消费者他们对于通讯无障碍，包括对于这个助听器的这个音频流播放，他们有些什么样的需求，包括在未来就是说这类产品的发展当中有哪一些痛点是我们的商业公司可能需要继续去处理的。那么 OK， 我们让小助手帮我们播放一下视频吧。浩辰。
Hello, my name is Linda Kozma. I'm a consultant and technology advisor to Hearing Loss Association of America. Previously, I was a senior research audiologist at Gallaudet University in Washington, D.C., where I specialized in telecommunications accessibility. In this presentation, I'll be discussing telecommunications access, specifically regarding U.S. policy and standards for hearing aid compatibility and wireless devices. To understand hearing aid compatibility in the United States, we must first start with events that happened 80 years ago. It is well known that the development of the telephone and its ability to control the loudness and frequency of sounds facilitated the development of the electronic hearing aid. What is less well known is the link between telecoils and telephones, which initially drove and today continues to influence U.S. policy and standards for hearing aid compatibility of wireless devices. In the 1940s, all American telephone and telegraph handset receivers leaked magnetic energy as a byproduct of their design. This magnetic energy was used to drive the diaphragm of the telephone receiver and generate an acoustic signal. American Telephone and Telegraph, or AT&T, had dominated the US market since the early 1900s, and by the early 1950s, AT&T served about 80% of the telephones in the United States. Other telephone handsets manufactured by independent telephone companies in the US and abroad use receivers that produced a much weaker magnetic field, which meant that inductive coupling was either less effective or not effective with these telephones. With the development of the transistor at Bell Telephone Laboratories, wearable body-worn hearing aids became available in the 1940s. At about the same time, patents were filed in the US for magnetic induction loop communication systems, or the telecoil. By the late 1940s, telecoils began appearing in hearing aids in the United States. A telecoil of adequate sensitivity could capture the magnetic flux from an AT&T telephone receiver and transmit the telephone partner's speech to the hearing aid wearer using the process of induction. Telecoils solve two problems with acoustic coupling of hearing aids and telephones: acoustic feedback and external acoustic background noise. Due to AT&T's dominance in the US market, the use of telecoils for telephone coupling became synonymous with the concept of hearing aid compatibility for the next 20 years. Telecoils are simple analog devices that have a metal rod wound with copper wire here. For maximum inductive coupling, the alternating magnetic field from the telephone receiver needs to cut across all turns in the wire of the telecoil. So the orientation of the telecoil relative to the magnetic field lines is important for optimal function. Amplified telephones here, or I should say amplified telecoils that are in use today, have preamplifiers to electronically increase sensitivity and adjust the input frequency response. In the 1960s, key technology transitions were happening in the US that impacted people with hearing loss and telecommunications access. First, residential telephone service was becoming standard across the United States. At the same time, hearing aids were becoming smaller, with behind the ear and in the ear models becoming prevalent. Component miniaturization included telecoils, and as telecoils reduced in size, their sensitivity also reduced. In addition, AT&T redesigned their handset receivers, and the field strength of the magnetic flux produced by the receivers also reduced. Contemporary hearing aid telecoils could no longer couple effectively to telephone handsets that employed the new receivers. So just as the telephone was becoming pervasive, telecommunications access for hearing aid and telecoil users in the US had become significantly compromised. By the 1970s, a grassroots consumers effort had taken shape to advocate for universal telephone hearing aid compatibility, and consumers took this advocacy message to Congress. As a result, 2 laws were enacted by the US Congress. In doing so, Congress recognized 2 things. They recognized there was a significant social cost involved in not having accessible telecommunications for people with hearing loss, and they recognized that market forces were not going to provide a solution to the access issue. The Telecommunications for Disabled Act became US law in 1982 and represented groundbreaking national policy for people with disabilities in the United States. The law established the right of people with disabilities to have reasonable access to telephone service. For people with hearing loss, this meant that essential telephones were required to be hearing aid compatible. What are essential telephones? Well, they're emergency phones and coin-operated phones. Those were considered essential. The Hearing Aid Compatibility Act, or the HAC Act, followed in 1988, but the actual rules were not finalized until 1996. The HAC Act required all new landline phones, 100%, to be hearing aid compatible, but exempted wireless phones from the same requirement. In the United States, once a law is enacted by Congress, it is sent to a regulatory agency to create the rules that put the law into effect. Agencies have considerable power to establish and interpret our US laws. Because Congress can't determine every parameter of the law, regulatory agencies fill in the details about the law and make it operate through rules and regulations that they adopt. These rules and regulations have the force of law behind them and can be changed to be responsive to changing issues and circumstances. Hearing aids and telephones are regulated by 2 different agencies. As medical devices, hearing aids are regulated by the US Food and Drug Administration, or FDA. Telephones are regulated by the US Federal Communication Commission, or FCC. It's the FCC that creates the hearing aid compatibility rules. So what does the US law, that 1988 law, say regarding hearing aid compatibility? Well, it says precisely that telephones must provide internal means for effective use with hearing aids that are designed to be compatible with telephones which meet established technical standards for hearing aid compatibility. It's a bit hard to understand, but basically, first of all, it means that the regulatory burden lies with telephones, because it is telephones that must be capable of working with hearing aids effectively. The means by which telephones are compatible with hearing aids must be internal to the telephone and not accompanied through any type of external add-on device or accessory. And finally, compatibility must be established using technical standards. This ensures reproducible measurements and permits comparisons among measured equipment. These standards include both the measurement methodology and performance criteria required to assess compliance with the rules. And there are processes and procedures in place for standards review on a periodic basis and for standards revision. Technical standards in the US are typically developed by an American National Standards Institute accredited body. Notably, the law is technology agnostic. It keeps the door open to allow new future technologies. However, at the time the law was enacted, microphone and inductive coupling were currently available technologies, so the technical standards were developed around those coupling methods. By 1996, the FCC had finalized the hearing aid compatibility rules. These rules required that 100% of new landline phones be compliant with the technical standard that had been developed. This technical standard addressed both acoustic coupling and inductive or telecoil coupling when a handset was held at the ear. For acoustic coupling, volume control requirements were set, which stated a certain amount of gain above nominal unamplified levels be available through the telephone. For telecoil coupling, requirements were set for magnetic signal field strength for both axial and radial components, and for magnetic signal frequency response. There were also labeling requirements for phones, so it was easy to identify if a phone was hearing aid compatible. Importantly, the FCC exempted wireless phones from meeting the hearing aid compatibility rules, even though digital wireless telephones had been known to be incompatible with many hearing aids as early as 1989. The FCC was unwilling to delay the deployment of digital wireless services and directed the wireless industry to work with other stakeholders toward a voluntary resolution of the compatibility issue. The technology transition to wireless phones and the use of digital rather than analog service created a new problem for hearing aid wearers. At the time, hearing aid users found they experienced annoying, audible interference when holding a wireless phone to their hearing aid that made phone calling very difficult and in some cases even impossible. The sources of interference included radio frequency or RF interference from cell phone transmissions. When in close proximity, hearing aid components could pick up those RF signals and then demodulate them by the nonlinear components in the hearing aid. The interference can occur during both acoustic and inductive coupling and sounded like a buzzing noise. For telecoil coupling, there was an additional source of interference, magnetic interference in the audio frequency range from cell phone electronics. In 2003, consumer advocacy, once again, accompanied by the sunsetting of analog wireless phone service, led the FCC to review and partially lift the wireless phone exemption. Hearing aid compatibility now, today, refers not only to inductive coupling capability, but also reduction in interference from the telephone handset. Acoustic volume control requirements were added later. Labeling and in-store testing of cell phones by people with hearing loss are also required. Compliant handsets are required to be compatible with hearing aids that have a reasonable amount of immunity, but not necessarily with every hearing aid. Because handsets can reduce, but not eliminate the RF emissions that cause interference, hearing aids need to improve their immunity to RF interference. And the move from analog to digital hearing aids facilitated that. Compliance for wireless phones is required for only a percentage of handsets. While this percentage has increased over the years, there has never been a 100% compliance requirement like there was for landline phones. In the United States, C63.19 is the technical standard that must be met for compliance with the HAC rules for wireless phones. To date, it has undergone 4 revisions. The most recent revision, C63.19, 2019, measures 3 things: the RF emissions associated with telephone handsets from microphone and telecoil coupling, the magnetic field strength, signal to noise ratio, and frequency response of the telephone handset for telecoil coupling, and the acoustic gain, signal to distortion ratio, and frequency response of the telephone handset for acoustic volume control. Each of these 3 elements are assessing performance of wireless phones held at the ear when coupled to hearing aids. There's also measurement methodology and performance criteria for hearing aid immunity, but compliance is not required. The 2019 version of C63.19 is going to take effect later this year in the US. Among consumer advocates in the United States, there has always been the goal of 100% hearing aid compatibility for wireless phones. To address this, and at the FCC's behest, a hearing aid compatibility task force was formed, comprising both consumer and industry stakeholders. This work was carried out between 2019 and 2022. There were 2 primary questions being asked. The first, is 100% hearing aid compatibility for wireless phones achievable? And 2, how could a 100% deployment benchmark rely in part or in whole on alternative HAC technologies? To answer those 2 questions, the HAC task force gathered information on available HAC and evolving alternative technologies and on consumer usage of HAC and alternative technologies. Before moving to discussing evolving alternative HAC technologies, it's worth noting that the current compliance benchmarks for hearing aid compatible phones is at 85%. In 2021, the FCC reported 93% of the handset models offered in the US by manufacturers were HAC compliant, and the largest 3 US mobile service providers, Verizon, AT&T, and T-Mobile, each reported compliance rates of 99 or 100%. These compliance rates are based on the 2011 version of C63.19, since the 2019 version of the standard is not yet in effect. Bluetooth is the evolving technology currently in use today as an alternative for coupling hearing aids and wireless phones. Due to Bluetooth power requirements, direct audio streaming between the wireless phone and hearing aids was not available until 2013, when Apple's Made for iPhone, or MFI technology, became available. This technology is proprietary to Apple and makes use of Bluetooth low energy technology. All models of iPhone support Apple's MFI protocol. Rather than utilize Apple's MFI technology in their hearing aids, Sonova took a different approach. And in 2017, Sonova introduced technology for direct audio streaming that made use of Bluetooth Classic, which was supported by both Apple and Android cell phones. Google followed in 2019 with their audio streaming for hearing aid protocol called Asha for Android phones. Asha, like Apple's MFI, is proprietary and uses Bluetooth low energy technology to implement direct audio streaming. Most recent Android handsets support the Google Asha protocol. To better understand the current usage of Bluetooth technologies in hearing aids and cochlear implants, the HHTF Task Force collected data for 862 hearing aids and cochlear implants that are currently on the market in the US in 2022. The data showed that more than 75% of hearing devices sold in the US support some variant of direct Bluetooth audio coupling to wireless phones. 28% support only Apple's MFI Bluetooth LE-based coupling method. 39% support both Apple's MFI and Google Android's Asha Bluetooth LE-based coupling methods. And 10% support only Bluetooth Classic. And those hearing aids are Sonova brands. In addition to the data the HHTF Task Force collected, Hearing Tracker, which is an online shopping resource for hearing aid consumers, shared their hearing aid database with the task force. Data on 806 devices representing the main brands and technology levels from 5 major manufacturers was curated from the specification sheets published by those manufacturers over a 10-year period. This chart displays data starting in 2012. That's 1 year before Apple introduced their MFI technology, and goes through 2021. The blue bars here represent the percentage of hearing aids that only have microphone coupling capability for wireless phone calling. The orange bars here represent the percentage of hearing aids that have both microphone and telecoil coupling options available. The gray bars, which begin to show up here, represent the percentage of hearing aids that have microphone and some form of Bluetooth coupling available. The yellow bars, seen here, represent the percentage of hearing aids that have all 3 forms of coupling available: microphone, telecoil, and Bluetooth. We can see in the chart that hearing aids with only microphone coupling capability, that is mic only, or microphone plus telecoil coupling capability, or mic plus T-coil, have been declining in favor of devices that also include some form of Bluetooth coupling. That includes MFI, MFI plus Asha, or Bluetooth Classic only. Hearing aids in the US generally remain on the market for approximately 5 years. Among hearing aids available in 2021 to consumers, the combined hearing aid tracker data for the 5-year period from 2017 through 2021 suggests that a little more than half, or 54% of available hearing aids included telecoils, while more than 3/4, or 80%, of available hearing aids were Bluetooth capable. In addition to the technology capabilities of hearing devices, the HHTF Task Force surveyed hearing device and wireless phone users to understand their behaviors and experiences regarding usage of wireless phones and direct audio coupling methods. This 2021 survey data was also compared to prior studies, including a survey conducted in 2014 by the Rehabilitation Engineering Research Center housed at Gallaudet University. Both the Gallaudet survey of nearly 500 consumers and a more recent survey by the Hearing Industry Association found that, like the general population of Americans, hearing device users have high rates of wireless phone and smartphone ownership. In 2021, the HHTF Task Force surveyed 800 consumers and found a majority owned an Apple iOS phone, 64%, over Android phones. Another survey by Hearing Tracker of 15,000 consumers found that improved hearing on a mobile phone was one of the top 5 areas that are of importance to consumers when purchasing a hearing aid. Comparing the HHTF Task Force and Gallaudet surveys, consumer satisfaction with their wireline phone experience, as well as the performance of their hearing device with their wireless phone, increased in the 7 years between the surveys. In 2014, Gallaudet University's survey found only 37% were either very satisfied or satisfied. In the 2021 HHTF Task Force survey, 60% were either very satisfied or satisfied. Another change that occurred during the 7 years between surveys was a decrease in the use of traditional acoustic and telecoil coupling with the phone held at the ear. This was in favor of other coupling methods that involve Bluetooth technology. Now, regarding interference noise being heard when the phone is held at the ear for phone calling, half of the 2021 survey respondents reported very rarely or never experiencing interference noise when listening to their wireless phone this way. The other half reported experiencing at least occasional interfering noise. This next chart shows consumer usage of HHTF and alternative technologies in 2014 and then again in 2021. We can see a substantial decrease in the use of microphone coupling as a preferred method for cell phone listening. That's shown here. There are smaller decreases in the use of the telecoil and Bluetooth coupling through a streaming accessory. Direct-to-hearing device Bluetooth coupling was the most preferred cell phone listening method among the 2021 survey respondents. It is interesting to note that even though 45% of respondents to the 2021 survey reported having a telecoil in their hearing device, only 5% use that telecoil as their preferred coupling method for cell phone calls. On the other hand, 64% reported having some form of Bluetooth coupling available with their hearing devices, and 47% used it as their preferred coupling method. While consumers report having a preferred method of coupling for telephone calls, the 2021 survey also found that consumers generally use on average 2 forms of coupling. That provides flexibility in accommodating different calling circumstances and needs. After considering the technologies available for direct audio coupling to cell phones and consumer usage of those technologies, the HAC Task Force formulated a set of recommendations. Regarding the question of whether 100% hearing aid compatibility for wireless phones is achievable, the HAC Task Force recommended a 100% HAC requirement to enable 2 possible coupling methods: acoustic, which is the most universal method of coupling available today, and then either telecoil or Bluetooth to enable magnetic or wireless coupling. In the 2021 survey, you'll remember, consumers reported using an average of 2 methods of coupling for wireless phone calling. Now, regarding the question of how a 100% deployment benchmark could rely in part or in whole on alternative HAC technologies, the HAC Task Force recommended, first of all, that 100% of wireless handsets must pass that RF emissions test. And second, at least 85% of those same handsets must pass the telecoil coupling test, and at least 15% of those handsets support Bluetooth. A phone that doesn't pass the telecoil test must support Bluetooth and vice versa. The HAC Task Force also recommended that any established technical standard for hearing aid coupling should be interoperable, non-proprietary, and adopted by industry and consumers alike. The new Bluetooth low energy audio technology with its hearing access profile is a non-proprietary interoperable wireless standard that represents a long-term goal for Bluetooth support in handsets. It is also anticipated that hearing device manufacturers will be including support for Bluetooth low energy audio in hearing aids and cochlear implants as well. US policy related to hearing aid compatibility for telephones has always been driven by strong advocacy from consumers with hearing loss. Technology transitions in telephones have mostly presented challenges to accessibility, either by taking away long-held access or by creating new barriers to telecommunications access. If uptake of this latest Bluetooth wireless standard becomes ubiquitous in cell phones and hearing devices alike, then Bluetooth coupling may become another universal method of coupling hearing devices to wireless phones as acoustic coupling is now. Bluetooth coupling permits sound to be directly transmitted from the phone to the hearing device and doesn't require holding the phone to the ear, which eliminates RF and baseband interference that can affect microphone and telecoil coupling. Additionally, consumers can more easily take advantage of other telecommunications access features now widely available as native accessibility features or applications on cell phones. These include video telephony, and that allows you to see your calling partner's face for speech reading. It also includes captioning of telephone calls, which allows you to read what your calling partner is saying. So what remains for accessibility, for telecommunications accessibility and wireless phones? Well, are there still barriers to satisfactory wireless phone communication for US consumers with hearing loss, even with the policy and standards in place to ensure hearing aid compatibility? Well, both the HAC Task Force and Gallaudet surveys identified several things. Environmental noise, which is common in mobile telephony, as a major barrier to telecommunications. Survey results also underscored the importance of speech quality in achieving satisfactory wireless phone communications. Hearing device features useful for wireless phone communication, while important, cannot overcome problems related to the inherent quality of the audio signal that's received by the hearing device. Factors related to audio encoding, such as codec audio bandwidth and bitrate, and network impairments, such as packet loss, are known to impact audio quality over wireless mobile networks. The surveys also highlighted the importance of usability for successful wireless phone communication. Whatever the coupling method, it should be quick, easy, and seamless to use both for making and receiving calls with a reliable connection between the devices sustained over time. Finally, and perhaps most important, is consumer education, especially for those individuals 70 years and older. Consumers expressed a need for more or better information about wireless phone communication options, more training on strategies to improve wireless phone communication, and better ways to test wireless phone products to find ones that work. I'd like to thank the Beijing Society of Audiology for inviting me to present on the topic of telecommunication access and United States policy and standards for hearing aid compatibility of wireless devices. I'd also like to thank Ke Yi-jin for her guidance as I prepared this webinar. Stella, I hope I didn't mispronounce your name too terribly. For questions, please contact me at lkozmaspitek@hearingloss.org. Thank you.
好的，非常谢谢 Linda 给我们做的分享。那么因为其实我们邀请 Linda 的话，我觉得可能我在年前的时候就已经在筹划这个事情，那也是非常高兴我们终于能够把 Linda 请过来做这样的分享。那么因为其实我们也知道，可能对于我们中国来说，对我们中国内市场来说，可能包括是电感或者是电磁感应先签，其实我们在日常的生活当中其实见到的并不多，更多还是像在特殊学校，包括可能一些特殊的一些公共场合会看得到。所以这个问题的讨论，可能对于我们国内的很多小伙伴可能不太能理解是，诶，这个是一个什么样的一个东西。但是实际上，如果我们有从事这个行业的人会知道，其实助听器的销售，我们经常看到会说带一个电感功能，而且这个其实在很长的一段时间以来，特别是国际的5大品牌的助听器在销售当中，基本上带有这个电感功能是类似于是一个标配的这么一个情况。那么，所以他也说到 ，Linda 也说到，伴随着这个因为蓝牙技术的一个进步，那么我们之前讨论到了很多助听器的这些电磁兼容性的问题，其实都会得到很大的一些改善跟进步。那么，而且我其实最关注是最后最后是他们 HAT 小组的话，在跟用户的调研之后得出来了，就是说对于这类这种无线通讯这些通讯无障碍上面来说，助听器用户他们需要的几个点，第一个就是说他们需要有一个优秀的这个音质。那就是说，除了这个 streaming 的部分，他们能不能保证这个音质听得更舒服、更好听一些？同时，如果是说在一些比如说嘈杂的环境底下，他们如果在接打电话的时候，怎么去处理到这一个通话降噪？包括就是言语当中的一些降噪的问题，这个也是无线麦克风在解决的一个问题。那么还有一个很重要一个点，就是说他讨论到说，在我获得这些无线的通讯的这些功能的时候，它的一个方便性跟可操作性。那么其实这个还是一个蛮关键的点，因为我们其实昨天在跟别人在聊天的时候，我们也讨论到说，包括我们在说这个无线的连接的时候，你在 App 的设置方面，包括我怎么去连接蓝牙，能够让我这个听的这个过程更加顺畅，其实是我们做的并没有想象中那么的好，因为我们很多消费者其实他是一个老人家，那么所以对于他来说，要怎么让这个操作变得更简单、更便捷，其实是我们很多需要去考虑的一个问题。 同时这也引出来的第3个问题点就是这个用户教育。那么如何把这个用户教育做好，让消费者知道说，这个是一个这个功能是有很好用。那么包括我们的商业公司其实也是需要做很多的一些推广，因为这个还是能够帮助他们得到一个更好的一个聆听，是这样的一个情况。那么我这边也分享一下，我们在20年的时候，我们曾经北京听力协会做了一个叫听力零售行业大家谈的一个问卷。那其实我们19年跟20年都做了这样的一个类似的一个问卷，我们主要面向的是这个行业里面的听力学家跟助听器鉴配师，由他们来给我们分享一下说他们在过去1年整个一个销售的一个情况。那么说在20年的这个数据，其实我们可以看到跟刚才 Linda 分享的美国的市场的环境其实是很相似的，就是在2019年到2020年的话，实际上这种手机直连的产品在过去几年还是获得了一个蛮大的一个变化，就是基本上有好多的人都反馈到说，整个它的一个销售是有一个大幅度的增长跟一个少量的增加。那么实际上我们如果再放眼再看这2年，包括5大或者是说我们知道的一些国产品牌，他们在推出新的助听器产品的时候，基本上蓝牙功能就是手机直连都已经成为是一个标准的配置，会是这么样的一个情况，所以还是一个蛮有意思的现象。我相信今天的这个分享也会让我们包括在政策层面上面会去了解到说，这些政策它的是怎么制定，会去影响到这些商业公司的一些改变。那么尤其也是要关注到我们国家这几年一直在提倡的一个通信无障碍，这个信息无障碍化。那么实际上在听力这一块，我们也可以看到在有一些政府有一些省市已经开始要求要去做这一些听力无障碍的这一些工作。那么只是现在的情况就是很多人都不知道说，我应该怎么去实现一个听力的无障碍。就除了我们说增加一个手语的翻译功能之外，手语的这个翻译功能之外，还有没有其他的一些是真正所谓的听力无障碍的一些设备跟设施？他说 Allocast 的话就是一个非常好的一个选择项。好的，